Listen. So guys, in the previous class, we have started with the concept of normalization, right? So basically, normalization means simply dividing a large table R into small tables called as like R1, R2 and so on, Rn tables. So the main reason why we are decomposing a large table into small tables means simply to avoid the redundancy. This is one of the main advantage of normalization. As we are going to decompose the table into small tables, we can able to eliminate various kind of anomalies also, right? So to define the relation is in which kind of normal form, we have framed various kind of rules also. That is like which is 1NF as well as which kind of relation is in 2NF. If I say that a relation is in 1NF, meaning that one normal form or first normal form, it has to follow basic properties, right? Then definitely I can call the relation is in first normal form, right? By default, when you are going to convert ER diagram to relational model, every pure conversion, meaning that every correct conversion will becomes under first normal form, right? So this first normal form problem is you cannot able to reduce the redundancy. You cannot able to reduce the redundancy. That's why we are moving to go for more stricter rules. That is what I can call it as 2NF, second normal form, right? This second normal form is saying that it has to be compulsory in first normal form and it should be free from partial functional dependencies. Free from partial functional dependency, I can call it as 2NF, meaning that if I say that there is a kind of a FD for the relation R, if there is a kind of FD is there, that is X determines Y, where X can be a kind of a candidate key. For example, X is a kind of a candidate key and this X may contain X1, X2, X3 for example, right? If this X can determine Y, X can determine Y, this is okay, right? When I can say that this is partial functional dependency, a part of it, right? A part of it, some assuming that Z, a part of it, Z, can able to determine Y, I can call it as partial functional dependency, right? So at this scenario, here Y can be a non-key attribute. Y can be a non-key attribute, right? So simply I can say this definition as a partial functional dependency. So our 2NF is more concentrating on to eliminate partial functional dependency. We have also seen like what is the reason why we are eliminating this partial functional dependency also. Like if you are able to observe this particular example, here if we take this example, AB determines is one kind of FD, as AB is a key, a part of it can able to determine the non-key attribute, so I can say partial functional dependency. So with our illusion we can able to divide this so that we can able to reduce the redundancy. That's the reason we made it more formalized way. That is what you can say this particular formula. So simply I can say that technically as it should be free from partial functional dependency. Right? We have seen various kind of examples also, right? So now this 2NF also cannot able to guarantee to reduce the 100% redundancy, right? So that's the reason we are moving for one kind of normal form, that is third normal form. Why 2NF is unable to eliminate 100% redundancy means if you take any kind of relation, for example ABC, where something like for example 1, 2, 3, 4 and 5, let us take this is A1, A2, C1, C2 and C2, right? So this is a kind of a relation actually we are having. So with this one, can I able to get various kind of FDs or not? Yes. Among those, one of the FD can be A determines B. Is it possible? As A contains all unique keys, A determines B. Similarly, is it possible for us to have B determines C? No. According to this example, no. But if I modify this to C2, is it now yes? Yes, it is yes, right? So B determines C is also possible. But if you are going to clearly observe, with this can I infer A determines C? Yes or no? If you take into real time example also, as all these are all unique keys, we can able to get the values of C unequally. Am I right? If I give the number 4, can I get the value C2? Yes. This is what the redundancy. Meaning that, so here also we can able to get some kind of redundancy. What is that redundancy? We can simply make split this table into again BC and another table is here, right? So that we can able to reduce the redundancy at the BC level. What are the values? A1, C1, A2, C2. So we have reduced many number of rows, and maybe this particular relation R1 may not reduce the relation rows, but it may reduce the R2 side. Right? So this is what we are thinking, right? So this particular thing cannot able to identified by the 2NF, right? What 2NF is simply saying, 2NF is going to concentrate only on partial functional dependencies, right? Partial functional dependencies means which are a part of the candidate keys. But if you take here, what is the candidate key here? Here, candidate key is A. Am I right? As candidate key is A, with this, can you say any partial functional dependency available here? There is no partial function because as single attribute is there, there is no subpart of it. So I can say that directly it is in 2NF. It is in 2NF, right? But if you are able to clearly observe, with this example clearly defines, there is a redundancy, right? So this redundancy means simply this kind of rule is what? Can I say that it is transitive rule? Rules చెప్పాను కదా, right? Transitive rule I can say. So meaning that 3NF means it has to be a minimum follow of the principles of 2NF, and also it has to be free from transitive functional dependencies. It has to be free from transitive functional dependencies. Then I can say that it is in 3NF. So what is the meaning of here transitive functional dependency, right? So if you are able to observe here, I am going to get the C column data indirectly with respect to one more common one more kind of a candidate key. Through what? Through a kind of intermediate non-key attribute. Then I can call here as transitive functional dependency for B determines C. Transitively determining some non-key value from the key value. Then I can call it as transitive functional dependency. So in other words, if I say, if there is any kind of relationship between non-key attributes, then I can call it as transitive functional dependency. If you take this example, B determines C. Is B is a candidate key or is B is a prime attribute? No. B is not a prime attribute. C is a candidate key or C is a prime attribute? No. Then I can say that this is transitive functional dependency. Simply, right? So meaning that wherever you observe any kind of relationship between non-key attributes, definitely it is violating the principle of 3NF. So at that situation, what you have to do? You have to split the table into multiple tables by using that respective functional dependency. So as you are violating the principle of transitive functional dependency at this level, you are going to simply find out the B closure. B closure is BC. So if you remove the C, you will get the remaining thing as A. So that's the reason we got the two tables. One is BC, another one is A. So this is what about the concept of 3NF. Okay, now in simple terminology, if I say 3NF is a 2NF and it has to free from transitive functional dependencies. Okay, fine. So guys, if you take the earlier class examples, if you take this one, first one, the relation here are of ABCD, where they have given various kind of functional dependencies, and we try to convert it into 2NF. So here R1 contains BD is the relation, R2 contains ABC is the relation. So which is now in 2NF, right? Now we have to find out whether it is in 3NF or not. So to define whether it is 3NF or not, what might be the functional dependency possible for here? One is B determines D, Another one is here for ABC. AB determines C. AB determines C. Now is it in 3NF? If I say to find out whether it is in 3NF or not, we have to check for transitive functional dependency. Is there any transitive functional dependency are there? Obviously no. Because like if you observe in this particular example, what is the key here? B is the key, right? B is the key. Here the key is AB. Here AB is the key. If you would like to say transitive functional dependency, definitely there should be a functional dependency which has the relation between two non-key attributes. Is there any kind of functional dependencies are available here? No. So as it is free from directly transitive functional dependencies, I can directly say that it is in 3NF. It is directly in 3NF. Okay, now fine. So to get more clarity, take out this particular example. So if you take this one, we have calculated already whether it is in 2NF or not. If it is in 2NF, there is no problem. As it is not in 2NF, we convert it into 2NF by making the three relations R1, R2 and R3. Right? If I take the relation R1, R1 contains the attributes are A, D, E, I, J, and R2 contains the attributes are B, F, G, H. R3 contains the attributes or columns are A, B, C. Now to define whether it is in 3NF or not, you have to find out various FDs possible. What might be the FDs possible here? A determines DE, very good, and D determines IJ. Is there or not? Yes. And coming to here, B determines F, F determines GH. Coming to here, AB determines C. Now with these things, can we conclude whether it is in 3NF or not? We can conclude, right? We can conclude it is in 3NF or not by following the transitive functional dependency property, right? If I are able to clearly observe, what might be the key here in R1? A. For R2 key is B. For R3 key is AB. Transitive functional dependency means non-key attributes relation, right? If you are able to observe clearly, this is a non-key attribute. This is also non-key attribute. I can say that this is transitive functional dependency, right? When I observe any kind of transitive functional dependency, you have to simply split the table. How can you split the table? By finding the decloser. Decloser is what? Dij. So I will make one more relation as R11, which contains the attributes are Dij. Once we write Dij, I and J are going to be eliminated. Am I right? I and J are going to be eliminated. What about the remaining one? A, D, E. So R1 I split it as R11 and R12. So we got the two tables. Now, is there any transitive functional dependency again? Is it possible? I mean, in this R11 or R12? No, because R11 contains D determines Ij, R12 contains A determines D. So there are no transitive functional dependencies. So R11, R12 are directly 3NF now. Now what about R2? R2 contains transitive functional dependency is there on F determines GH. So you have to split this table into again R21 and R2. So that depends on the way we are splitting. So what might be the R21? FGH. So if you remove G and H, and for R2 you will get B. And anyway, for R3 you are going to have AB determines C. Now is it in 3NF? Right? So for R21, what might be the FD possible? F determines GH. For R22, B determines F. If you are able to clearly observe, all our functional dependencies are free from transitive functional dependencies. So I can say that now it is in 3NF. Okay, now fine. So it's simply a 3NF. Or else, if you want, you can just clarity. If you are going to have only one FD possible on a relation, in a relation, if only one FD is possible, definitely it will follow 3NF. Why? Definitely one should be a kind of candidate key. If it is a candidate key, then only it will become under FD. Right? So if you take here, D determines Ij, as only one FD is possible, only one FD is there, definitely that should be a kind of a key. So once it is a key, definitely it is going to be a kind of free from transitive functional dependency. So if you are able to observe, R1 contains one FD, R12 also contains only one FD, so directly they are in 3NF. Here also R21 contains 1 FD, 3NF. R22 contains only 1 FD, we can call it as 3NF. Here also only 1 FD, we can call it as directly 3NF. So combination we can call it as completely 3NF. Right? And one more thing, important point here. If you are able to observe any kind of FDs, any kind of FD relations, if you take R1, R1 contains how many attributes? 2 attributes, right? If there are 2 attributes, what might be the FDs possible? One determines one other one. B determines D, another one is D determines B, right? Anyway, at least one will be a kind of a candidate. One kind of a candidate B. Then is there any redundancy possible when a relation contains only 2 attributes? If a relation contains only 2 attributes, is there any chance of getting the redundancy? Definitely not, because at least one should be a kind of a key. Am I right or not? So as at least one will be a kind of a key, definitely there is no redundancy, meaning that when a relation having only 2 attributes, definitely it is going to be having 100% free from redundancy. This is important one. When a relation having only 2 attributes, definitely it is free from the redundancy, right? So we can say directly that it is in BCNF also. This is next level of normal form I am going to discuss, which is directly in BCNF. BCNF is going to be completely free from the redundancy. Okay, fine. Next, if we take the third example, we have find already 2NF relations. One is R1, R2 and R3. Is there any kind of transitive functional dependencies are there here for R1? A determines FC, C determines D. C determines D, right? So when you say that here, so A is a kind of a key. Once A is a kind of a key, is it a transitive functional dependency? Yes. Once it is a transitive functional dependency, what you have to do? You have to split this into multiple tables. One is CD table, another one is AFC table. AFC table. Okay. So now it is free from the transitive functional dependency. What about the BE relation? There is no transitive functional dependency. What about R3? There is no transitive functional dependency. So I can say that now, after splitting this into multiple tables, one is for R11, one is CD, for R12, another one is AFC, for R2, BE, R3, AB. Now it is in 3N, because it is having purely free from the transitive functional dependencies. Okay, now take out the fourth one. We have already got the solution of 2NF. Solution of 2NF. Now, is it free from the partial like transitive functional dependencies? If you take ABE, A determines B, B determines C, B determines E is a kind of a transitive functional dependency. So we have to eliminate, right? So if you take R11, B is one relation, R12, AB is one relation. AB is one relation. And what about R2? CD as this, R3 is also as this AC. Right? Now it is in 3N. Means we are simply concentrating only on transitive functionality so that you can able to reduce the redundancy. Right? Similarly, for the fifth one, for ABC, what might be the FDs possible? AB determines C. For BDF, BD determines EF. Good. For ADGHJ, AD determines GH, H determines J. H determines J. For AI, A determines I. For ABD, any functional dependency may be possible, right? So if you find out the AB closure is ABC. Can we get anything like related with A closure? A closure with respect to BD. I mean, how we are going to find out the various functional dependencies? We are going to start with single FDs, 2 FDs, then 3 FDs. 3 FDs anyway not possible, because see, 3 FDs are possible, but they are comes under trivial FDs. So we should not consider, because they are always going to be satisfied. So we have to find out A closure, B closure and D closure. So anyway, there may be some possibilities are there. Okay, fine. But according to the visibility here, we can able to observe these two. Here H determines J is what? Trans to functional dependencies. Trans to functional dependencies. So I can able to simply divide this relation into one is Hj, another one is ADGH. Right? So total how many relations are possible here? If you want to make it in 3NF, 1, 2, 3, 4, 5, 6 relations are required in order to make the given relation should be follow the properties of 3NF. Right? So this is what all about the concept of 3NF. Right? So this 3NF also cannot able to compete when you are going to have more than one candidate key actually. When you are going to have more than one candidate key, sometimes it may work, it may not work. That's why we are moving for one more kind of normal form, that is BCNF. We can simply call it as Boyce-Codd Normal Form. BOYC. Boyce and Codd, these are two scientists. Boyce-Codd Normal Form. Here, what this normal form is defining is, if I say any kind of relation instance R, and if there is any kind of functional dependency which is following X determines Y, X should be compulsory a key or a super key or a candidate key. That's it. So if you follow this principle, I can say that the relation is in the BCNF, right? So this BCNF is going to eliminate complete redundancy, meaning that it is going to be 100% free from the redundancy. Why? Anyone? 100% free from the redundancy. Any reason? Because left side is a kind of a key. If left side is a key, what is the meaning of it? If left side is a key, definitely it contains all the unique keys. When all the unique keys are there, is there any chance to delete any data? No. So that's the reason it is going to be in BCNF and it can eliminate the redundancy. See, for example, if I take any relation R of ABC which contains 1, 2, 3, assume that A determines BC or A determines something. As A is a kind of a key, is there, can you say that any redundancy is there? Definitely not, because we cannot able to eliminate any other things. If I eliminate also, this particular data is going to be lost. That's why it is going to be free from the 100% redundancy, and they are going to concentrate only on LHS side should be a kind of a key. Right? So if I extend the same concept to 3NF, here I have explained 3NF means it should be follow the principle of 2NF and it has to free from the trans to functional dependency. If I say more technically, it has to be follow the principle of 2NF, and also if I say that a functional dependency X determines Y is possible, X can be a key or a super key or a candidate key, super key or a candidate key, or Y can be a prime attribute. So indirectly, this particular definition is following free from the trans to functional dependencies. Right? If you are able to observe, if I say that left side is a key, is that FD will be comes under relation between non-key attributes. If I say that if I say this one is left side is a key according to this definition X, left side is a key, then it will be comes under trans to functional dependency? No. So for example, if I say that right side is a prime attribute, can I say that this will be comes under trans to functional dependency? No, because trans to functional dependency means what? Both sides should be definitely non-key attributes. So indirectly, this particular definition is following this principle only. Am I right? So this is more technical, right? So X can be a key or a super key or a candidate key, or so you have to make sure this point, or anyone can be satisfied. Anyone can be satisfied. But coming to here, coming to BCNF, it is not or the case. It should be definitely a super key or a primary key or a candidate key. Okay, meaning that BCNF is more stricter than 3NF, because 3NF having a chance of giving that it may not be a candidate key also. Only right side may be prime attribute, right? So that is also eliminated in BCNF. Okay now. So if you take example, take out this one only. First one. Is it in now BCNF? Obviously it is in BCNF, right? Because if we take the in 3NF FDs, B determines D is there, and left side is already a kind of key. Is also a kind of a key. So I can say it is in BCNF. Or let us go with first 3NF. Right? 3NF rules are what? Left side is a key, right side is a prime attribute. Right? Left side is a key, so 3NF. Here left side is a key, so 3NF. Okay now? Fine. So it is in 3NF. What about in BCNF? Left side is a key, left side is a key, so it is also in BCNF, right? What about here? Here left side is a key, here left side is a key, here left side key, and left side key. As all the left sides are key, it is following 3NF, and the same rule will be applicable for BCNF also, right? Which is also as for BCNF. Am I right or not? Right? So, but there are certain situations where every 3NF cannot be a BCNF. Am I right or not? Because 3NF having a chance of right side can be a prime attribute. Right? So that is the reason 3NF cannot be a BCNF, but BCNF definitely a kind of a 3NF. Okay, now fine. So take out this one here. So C determines D is a kind of a key left side, so it is in 3NF. A determines FC key, B determines E is a key, and for this it is following, right? So it is again a 3NF, as all the LHS are in LHS are in the keys, so I can call it as BCN. What about this one? Same, it is also in 3NF. According to the technical definition of 3NF, it is in BCN 3NF, and also it will be in BCNF. Why BCNF? Left side is always a key. B determines C, A determines B, C determines D. As all are keys, definitely it is going to be BCNF. Similarly, for this also, if we consider H determines J, BCNF, AD determines GH is BCNF, and AB determines C is BCNF, B determines EF is BCNF, and this is also in A determines I is also BCNF. So everything will be following. So it is also in BCNF. So I mean, if I say clearly, BCNF is more stricter than 3NF. That's it. Right? That's the reason BCNF is going to eliminate 100% redundancy. Right? So sometimes you may get chances that question may be like this, like which of the following can eliminate the complete redundancy. The option may be BCNF also. When option is in BCNF, you can select the option as BCNF. But some situations BCNF might not be there. Then obviously you have to select as 3NF. If 3NF is not there, that is what we did mistake, right? 2NF definitely won't allow redundancy, won't eliminate the redundancy. 3NF and BCNF eliminate the redundancy, but BCNF definitely allow the remove the redundancy. 3NF may not, but if BCNF is not there, definitely 3NF is the answer. Okay, so take out this example. Let me have R of ABC. There is FDs are there. AB determines C, C determines B. C determines B. So can you tell Is it following? What is the maximum normal form it is following? Maximum normal form follows. Obviously, is it following the 1NF? Definitely it will follow 1NF. We have to check with only 2NF, right? 2NF means what? It has to be free from partial functional dependence, right? So for this, first what you have to find out? You have to find the candidate keys. What meant by the candidate keys? AB is one candidate key. ఇంకేముండొచ్చమ్మా? AC is one candidate key, right? Now is it following the 2NF? Is it following the 2NF? No or yes? What does the meaning of partial functional dependency? A prime attribute should derive other non-prime attribute. Very good. Exactly. It has to derive other non-prime attribute. Okay now. So then only it has to be follow partial functional dependency. But if you take this example, anyway AB is a key, there is no problem with this one. But if you take C actually a prime attribute. It's a prime attribute. You may think that it's a kind of partial functional dependency, but it is not. Why? The right side is a non-key attribute. Right side is a key attribute, right? Right side is a prime attribute. Why right side is a prime attribute? AB is a candidate key, B is a prime attribute, definitely, right? As right side is a prime attribute, it is not partial functional dependency. Okay now, so you have to take care of this situation also. What about, so as it is not partial functional dependency, can I say that it is in 2NF? Yes, it is in 2NF. What about, is it in 3NF? It is in 3NF. When you say that it is in 3NF, so according to the definition, left side can be a key or right side can be a prime attribute. If you are able to observe here, the candidates keys are here A, B and AC. If you take out the prime attributes, A, B, C are the prime attributes. Once all are prime attributes, definitely on the right side also prime attributes are there. So I can say that there are no transitive functional dependencies. I can say that it is in 3NF. But what about BCNF? BCNF is not. Why? AB is a candidate key, there is no problem. What about this one? C determines B. C is not a candidate key, so compulsory it is violating the principle of BCNF. So you have to find out the closure. What is the closure of C? CD. CD is one relation. Sorry, CB. CB. If you remove the B, the remaining thing as AB. So now it is in BCNF. Because C determines B is one kind of FD, where C is a kind of a candidate key. And what about here? AC or AB? Yeah, okay, AC. Very good. AC. So A determines C or C determines A can be one thing, right? Okay. So instead of writing directly like this, what you have to do basically, you have to find FD summa. So I hope you understood up to here, right? Is it now BCNF, right? If I find out the C closure, what are the FDs possible here? C determines B is one possible, directly we can write. What about B determines C? B determines C is possible? No. If I find out the B closure is B only, so it is not possible. So only FD possible for here as C determines B. What about here? What is A closure? A. What is C closure? CB, and you cannot able to get anything. So this C is not a step. So total entire thing is a kind of a key. Okay now, fine. Now, as it is in BCNF, is it satisfying lossless join property? Is it satisfying attribute preserving property? Is it satisfying functional dependency preserving property? Tell me. it is satisfying lossless join property. Why? When you are going to combine, the combination should be definitely a common kind of common column. If you are able to observe here, the common column is C. So definitely it is going to yield lossless join property. What about attribute preservative? Definitely is going to be yielded because we are trying to check every time. What about FD preserving? Maybe, may not be. With this example, I can say that AB determine C is not possible, right? So here FD preserving is not possible in this particular example. So with this example, I can conclude that if I say that everything is a kind of one kind of a normal form, they are going to always satisfy lossless join property, right? And attribute preserving also always has to be satisfied. That is what I am saying from the starting onwards, right? These two have to be compulsory satisfied, and FD is the optional one. Functional dependence preservative is the optional one, right? If you take the BCNF is also going to satisfy lossless join property, attribute preserving property, but FD may satisfy or may not be satisfied. BCNF may satisfy or may not satisfy functional dependency preservative. Point. May not satisfy the FD preservative. What about 3NF? 3NF is going to satisfy all the things, almost cases. In almost all the cases, it is going to satisfy lossless, attribute, and FD preserving also.